following presentation is brought to you by Group
105.
Section number 1, with Raul Vargas as our instructor. Our group consists of
Mike Allen,
Crystal Ferreras,
Miguel Blanco,
and Zachary Finch. We hope you enjoy.
Our project concerns Bernoulli's principle, which applies to water under pressure and how it is affected by the materials that push against it. Another part of the principle applies to how the sound waves pass through the water and while it is under pressure.
We will be conducting experiments to show how sound waves pass differently through different materials. The way this affects our industry is that as recording arts majors, we can have jobs in post-production sound for movies and video games.
This principle can come in handy if a movie was being made about life underwater, kind of like a documentary about fish, or maybe even an action movie with underwater scenes and explosions. So, let's begin.
So, Miguel, I was wondering, could you explain Bernoulli's principle to me? Because I honestly do not get it.
Of course I can.
What was your hat?
I can help you with that, sir. Bernoulli's principle basically states that as the speed of a fluid increases, its pressure decreases.
It doesn't make any sense, man.
You'd be surprised. Imagine a pipe, right? It has water flowing through it at a certain speed and certain pressure. What is pressure?
What is pressure?
Force per area. Now, that is determined by how the particles are grouped together in the fluid. If the particles have enough space between them, in other words, if the area is bigger, then the pressure decreases. Likewise, if the area between them is smaller, the pressure increases.
Okay, well, what does this have to do with Bernoulli's principle?
Well, imagine a narrow section of a pipe. As water passes through it, its speed increases because it has to move at a constant rate. Because it is going so fast, the pressure decreases.
It decreases?
Yes, it does, sir. Fluid speed and fluid pressure are actually inversely proportional. As one goes up, the other goes down, and vice versa.
Okay.
Now you know, and knowing is half the battle. So, Mike, how exactly does Bernoulli's principle apply to sound waves?
Well, when the sound waves pass through a material, any material, it decreases the volume and intensity of the sound. To understand this, we need a gallon of water, a decent speaker, and some sound equipment.
Well, I don't have a gallon of water, but I have Pringles can. Can that work?
That will work, but what about a speaker? That's a small speaker.
It worked. Trust me, I'm Russian.
Well, I have the sound equipment.
Let's do this, shall we? It's full of water and lots of it. We have to be really careful now because this can seriously damage all equipment we're using. These Russian hands will take care of the job. So, we're going to play this song, Rock and Roll by Skrillex, at same point.
See how that works?
Yeah, kind of. But how does it work with other materials?
Well, let's find out. We now need a bottle of air and a cloth.
Well, I have Pringles can and I have cloth.
Let's begin.
Yeah. Okay, so now we're going to do this with a hollow Pringles container. I removed towel and now it is empty. Same point, same out, and same music. So let's check this out.
We've concluded that sound waves are in fact altered differently as they pass through different states of matter. As predicted, gas offers no resistance for the sound waves at all. Solid gave the most resistance, and liquids was somewhere in between. And this concludes our little experiment. Thank you for watching our presentation, and we hope to see you soon. Next week, we'll attempt to light a room full of art scene with a lighter.